Okay, so I'm going to start a new drawing here, and I'm going to do, we're going to create a three-dimensional body, and the first one we did was an extrusion, and that's a way to take a two-dimensional sketch and turn it into 3 dimensions. Another way is to do a revolution or revolve. So that would be kind of like if you were working on a lathe and you had a profile and you spun it and you used that to cut out a part. So I'm just going to show the process for that. And with this recording program, I've enabled a little indicator right here that tells you which button I'm clicking. So that'll make it a little easier to understand what I'm doing, and also it'll record keystrokes. So anytime I press something, it's going to show up there for a second, and that'll help you understand what I'm doing. So the first step is we're going to have to create a sketch, and a sketch needs to go on a plane. So what I'm going to do is open up the origin here, and that's going to give us all of our named points and axes and construction planes. So I'm going to just go ahead and okay, I don't know why that's doing that. No. Anyway, so I'm going to right click and create a sketch on that plane. I'm going to zoom out, and the first thing I'm going to do is create a center line, because I'm creating a revolution, so that means that everything is symmetrical from one side of that center line to another. So right here you can see our line types. So if I take a line here and just extend it and then escape out, you can see I can move that around. And this little indicator here tells me that this is a horizontal line. So anything I do to this is going to keep it horizontal, right? So what I want to do first is I want to bind it to my origin, because right now I can move it around, and I don't want that. So I just click it, and then shift-click my origin, and then create a coincident constraint, and escape out of that to get back to our regular select mode. Also, anytime you're in a mode other than select mode, you can see that the cursor has that sort of icon for that mode right next to it. So that tells me that I'm picking points for a coincident constraint, or I could be picking points for a vertical horizontal constraint. So right now I just want to have the standard select mode. So to turn this line into a center line, I'm just going to click it and then select the center line there. And we can see that because this line is black, that means it's fully constrained. So I can take it and try to grab it, and I can move the endpoints a little bit, but this line is not going anywhere. Now, what I'm going to draw here is a wheel hub. So this is something I build a bunch of, so I'm familiar with it. And the first thing that we're going to do is just start to draw our profile. So grab the line tool there, and I'm just going to sketch out, roughly what the wheel profile looks like. So one of the things you might notice is that I'm not putting any dimensions in here. I'm just kind of rough sketching everything in. I'm going to put a circle in here for the middle part of the wheel. And you can see that the circle, again, is not constrained in any way. So I want to kind of bring it in here. So I'm going to click the center of the circle and the origin, and I'm going to make those vertical. Let's get out of that mode. So now you can see that my circle is constrained in the vertical, but it's not constrained in size or in the radius there. So one of the things that I want to have happen on this is I want the circle to line up tangent with the inside face of the wheel hub. So I've selected that line and that circle, and I'm just going to make that tangent and then escape to get out of that mode. And now you can see that the relationships are still kind of flexible, like I can still change the diameter of the circle, but it's always going to be tangent to that line. So what we're doing as we're sketching is we're kind of building up the shape, and then we're kind of constraining it. And that's going to create our finished part. And what you'll notice too is that as I constrain these features, they're going to change color from that blue, and they're going to change color to a black. And when that feature is black, it just basically means that it's fully defined. You can't drag any of it around. So it's kind of locked in position, but I can still go in and change relationships or change dimensions to modify that feature. But by being constrained, it's going to be modifiable in a predictable way. Okay, so I'm just going to start putting some dimensions in. And actually, so this is a center line, and this side of the hub is actually going to be reflected across our center to the other side. It's going to be a mirror. So what I'm actually going to do is create another center line that goes up here, and then make sure you use center line. For this stuff, don't use construction line. They're different, and they have different properties. So what this is going to let me do is it's going to let me dimension this feature across that center line. So if I wanted my wheel hub to be 4 inches in width here, and I just had a construction line here, so I'll just demonstrate this to you, right? So right now I've got 4 inches, and let me just drag things back around to make this make sense. And so SolidWorks is a little nicer because it will kind of automatically adjust things. Like when I created that dimension, it sort of broke my sketch a little bit. So that's one of the things about Fusion that I don't really like, but you learn to work around it. Okay, so I'm going to delete this dimension, and I'm going to show you what this would be like if it were a construction line. So you can see now it's got a different dot pattern. And I'm going to go ahead and try to dimension this again. And you can see all I can get is that 2 inches, right? Because it's not going to assume that this center line is representing a mirror of these features to the other side. So that'll make a little more sense later. And if you studied technical drawing, it would make a lot of sense. So that's a feature that I do like about Fusion, is that it's pretty accurate in terms of standards for technical drawing. So I changed that back to my center line, and I'm going to dimension that feature again, and then just hit enter. Okay, and I'm going to just come in here and start dimensioning the rest of my features, and that'll fully constrain things. So my inside thing here, let's make that 2.5 inch diameter, and I want to kind of lock in that circle. So let's make that 5 inches, and then I want that face where the spokes are going to come out to be a little over 1/8 of an inch. And here's a trick that I find really useful. Sometimes it's kind of difficult to remember what your fractions are. So like usually if you want 1/8 of an inch, it's 0.125. That's, everybody knows that. And I know that I don't want it to be 5/16 of an inch. I think that would be a little too big, so I want it kind of in between. So I can just go ahead and add a 32nd of an inch. So 0.03125 from memory. And it'll just go ahead and add everything together. So you can put these little mathematical expressions in your dimensions, and that'll save you some time so you don't have to look at a calculator. And I find that to be a pretty useful thing. So I'm just going to go ahead and dimension my overall hub diameter. And I think I want that to be 6 5/8. Okay. And this guy, I think I want this to be, call it 60 millimeters. Now, right now this drawing is in default inch mode, but that doesn't mean that you need to pull out the calculator to put in some millimeter measurements. So all you need to do is just put in 60 and then millimeter, and it'll automatically convert that for you, which is a pretty useful tip. Now, if you wanted to kind of make it more clear to yourself that that's a metric measurement, you can right-click on that dimension, and you can actually go in and okay, never mind. That's something you can do in SolidWorks. I haven't figured out how to do this in Fusion yet, I guess. But there's something called the dual dimension, and what that'll do is it'll show your inch dimension, and then down here in parentheses, it would show your millimeter dimension, which is pretty handy when you're kind of mixing units. Anyway, I'm going to keep going and, dimensioning the drawing. Okay, so now you can see everything is in black. So that means everything is fully constrained. So if I go into regular select mode, I can't move anything around, right? Because all of the dimensions that define the features have been specified. So if I take this one out, I can move the circle diameter around. But if I put it back in, everything is fixed, right? And that's a good sign. You want all your sketches to be fully defined like that. And there are reasons that I can go into more detail later. Now, the thing about having a fully defined sketch is that this doesn't mean that I'm going to have to wipe out my entire sketch if I want to change something. One of the really powerful things about parametric modeling is I can go in and just change a dimension, and it's really easy to do. So the general process for designing stuff like that is you really want to rough everything out, and then you go back in and you kind of fine-tune things. So, I know that this is probably a little wide for, a wheel hub. This angle here is going to be, kind of weird to have your, spokes sitting on or whatever. So I can go in here and play with stuff. That's okay, but I want this to be smaller, so let me increase the diameter of my circle. And so that's one way to do it. But also, if this is a critical dimension, you're kind of stuck right here, right? This dimension isn't defined. Like the distance from here to here isn't defined. But if, let's say, I needed that dimension to be a specific dimension, then I know that this dimension here, like let's say the diameter of this circle isn't really important to me because it's just, kind of bridging the gap between this side of the hub and that side of the hub. So I can just go ahead and take that dimension out, or I can right click on the dimension and do what's called a toggle the driven. And basically what it means is that there are two types of dimensions in parametric modeling. There is a driven dimension and there is a driving dimension. So right now, because this is in black, it's a driving dimension, which means that when you change this, it's going to change the diameter of the circle. So I've made the circle kind of a critical part of this design. Now, the circle, to me, isn't a critical part of this design. It's just bridging the gap from here to over here. So I'm going to right-click this, and I'm going to toggle driven, and you can see it's in parentheses now, and it's a little grayed out. And essentially what that means is it's not I guess, fully constrained would be the way I'd define it. So that gives me the flexibility to come back over here and define the distance between these 2 points. And so just watch what happens when I do that. So I've got 1/8 of an inch now, and let's say I wanted 6 millimeters. So I'm going to key in 6 millimeters, and you can see that this dimension changed, but the sketch is now fully defined. So what this dimension is telling us is that it's not being used to set the diameter of this circle, but it will tell you what the diameter of the circle is, if that makes any sense. Okay, so the next step of the process is, because I've got this part of the hub and I want to reflect it across the center line, I'm going to use a tool called Mirror, which is that guy right there. And alternately, you can go down here and you can find a lot more sketch tools that you'll end up using later. So I'm just going to click Mirror, and it's going to ask me to select the objects and the mirror line, which is, I think, pretty self-explanatory. So this is just, what do you want to reflect? And that's, what do you want to reflect it across? So I'm just going to go ahead and pick the geometry. And then go ahead and highlight the mirror line. I'm going to pick our center line. And this is going to give you a preview of what everything should look like. Mostly this is good to look at to make sure you didn't forget any of the geometry over here. But it looks like we're good, so I'm just going to click OK. And you can see that this side of the sketch, even though it doesn't have any dimensions, it's still fully constrained. And the reason it's fully constrained is because it exists purely as a mirrored image of this part of the sketch, which has been fully constrained. So the final step for me is just to go in and trim some things. And all you got to do is click the trim tool. And then you can see that if I hover over that line, it's going to show me in purple what's being removed and then what's kept. What's kept is in blue and what's removed is purple. So just click it. And you'll notice too that your center lines and your construction lines also will trim your geometry. So sometimes if you have a drawing with a lot of these, it gets to be kind of a pain in the butt. So use these, I don't want to say sparingly, but be aware that if you have a lot of these, it can be kind of a hassle when you start trimming things. And same here, and same there. Now, oddly enough, when I did that, this line here became unconstrained. So that's kind of interesting. So I'm gonna drag it around and see exactly what's going on. So what it looks like is that the line is not necessarily a vertical line. So what I'm going to do is just click it, and then I'm going to constrain it to being vertical. And then you can see that that brought back the fully defined status of that line. So that's really important, that everything is black and it's fully defined. Because when you start going back in and editing geometry or editing your sketches, you really want to make sure everything is fully defined. Otherwise, you can change one thing and then the entire sketch just completely blows up. You have lines going off into infinity and just all kinds of weird stuff. So just avoid that. So now that we've got the sketch defined, I'm just going to finish the sketch. And then what I want to do now is create a revolution. So under my solid tools, I can go down here and create a revolve, or I can just use the quick one up here. Either way. So the first thing I'm going to do is select the profile. So these are both kind of separated by that center line on the sketch, so you want to make sure you select them both. And then the axis to spin them around is going to be that. There are a couple other tools here that we don't need to worry about for this particular operation, but I'm going to show you more about that later. And then just click OK. Now, one of the things that I like to do is I like to name the solid bodies, and I also like to name the operations. So I'm just going to call this the hub base, and then I'm going to name the sketch the hub profile. And I'm going to go down here and right click and rename this the hub revolve. Okay, and this is helpful because as your models get more complicated and you have to go back and edit things, it can be a lot quicker if you have some name that makes sense rather than, body number 1 or body number 17, or sketch number 1 or sketch number 47. This gets to be a real time saver, so this is a good habit to develop early on. Okay, so the next thing I want to do is I want to create a through hole, and then I want to create some bores that are going to hold our bearings and our seals. So what I want to do is go back and just look at the profile head on, and I want to create another sketch. And what I'm going to do here is a revolved cut. So I'm just going to create a sketch here. Now, I want to be able to use the geometry of the hub, especially the hub edges, so that it's a lot easier to do that when this is just a line drawing. And the way that you do that is you go into display settings and then visual style, and I'm just going to change it to wireframe. And when you go over here, one of the things that you want to be able to do if you want to use the three-dimensional geometry in your sketch is you want to show projected geometries. Okay, if you have that unchecked, I'm not going to be able to snap to edges like that, right? The sketch is going to ignore that. So you want to have that on, and you also want to have 3D Sketch off in this instance. And what 3D Sketch would let you do is, if this were on, I could draw a sketch that doesn't just stay on the sketch plane. So I could actually have lines that come from the sketch plane and might intersect our hub like up here. So in some cases that's what you want to do, but in almost every case you don't want to do that for this. So this is an important thing to make sure you have turned off. Okay. So now I've kind of screwed up my orientation again. And the quick way to get back to looking at your sketch as if it were just graph paper, like you just want to draw on it, is right-click the sketch and you click Look At. Okay, and that brings you up perpendicular to your sketch again, which is where you want to start drawing things. So I'm creating another revolved feature. So the first thing I want to start with is our center line. So I'm just going to click line, center line, and I'm going to draw a horizontal line, and I'm going to constrain it to the origin. Okay, you see the line is black, we're good to go. So the next thing I want to do is rough out our bearing bores. And because this is going to be reflected again, I want to create another center line that comes off the origin. And then I can use that to reflect features across. And I'm just going to go ahead and draw a feature just like that. And what I want to do is constrain that to the edge of our hub, because this is going to be a hole, so obviously it's going to have to be constrained to that. So the way I do that is just click both features and then click coincident. Now, what I need to do in order to have this cut feature out is I actually need to have a closed profile. So I need to go ahead and bring this profile back down to the origin. So when we spin it, it's going to create kind of a solid, right? So you can see that this is our profile here. Now, this purple indication here means that I've used some projected geometry to inform my sketch. So I can actually go ahead and kind of make that invisible if it's getting a little bit confusing. And I think the way we do that is we click that. Okay, and then that's going to clear the drawing up a little bit. And just right click and then look at, and that's going to bring me back to my sketch. All right, so I've got the general shape of this, and the first thing I want to do is mirror. So I want to mirror, these lines, and then I want to mirror them across that feature. All right, and I'm going to start dimensioning things as far as diameters go. So let's make this 1 7/8 for our diameter. Okay, and then our bearing bore, I'm going to use 52 millimeter bearings for this thing, so let's just call this a 52. Well, actually, you know what, to be correct, let's do a 51.95 millimeter, because that would give us a press fit for that bearing. And I know that the depth of this bearing bore is going to have room for the bearing and then room for the seal. And I know that my bearing is a 15 millimeter width, so I'm going to put in 15 millimeters. And then I also know my seal is a 7 millimeter seal, so I can do that. So again, I'm using an arithmetic expression and then millimeters for my units. And there you go. It just converted everything for me. And you can see everything is fully constrained. I've got all my dimensions here, and that profile looks like it'll be closed when I spin it. So I'm going to finish the sketch. All right, and what I want to do is create another revolve. So I've got this sketch highlighted right now, and I'm going to create a revolve. So the profile I'm selecting is that, and then the axis I'm spinning it around is that. Now, what I'm going to do here is I'm using the revolve tool, but some of the options in the revolve tool are you can create a new solid, or you can do something like a cut or an intersection. Typically, you're going to use a join or a cut almost all of the time. So what it did is it actually defaulted to cut mode because it saw that I'm creating this sketch inside of another solid body. So it's intelligent enough to know that this is probably what you want to do. But this is one of the options that you can configure to do different things with the same tool. And as far as objects to cut go, there are some cases when you have different solid bodies and you do an operation, and maybe you want it to only do the operation on one body, even though it extends through a few of them. So you can actually go in here and just select which bodies you want that operation to complete with. Yeah, so I'll show more of that later, but just go ahead and click OK. All right, it's thinking. And what I'm going to do is go back in Display, Visual Style, and then go back to Shaded with Visible Edges Only. And you can see there's short keys here too, so if you want to get kind of quick with using Control-6 and Control-7, these are the modes of display that you're going to use the most. They're the most useful. So just click back on that, and we can see we've got, you know, something started here, looking pretty good. All right, so this sketch I'm going to name as my bearing bores, so it makes sense. Yeah, and typically you want to name the sketches more than you want to name the actual features, because the sketch is the thing you're going to change in most cases. Okay. So the next thing I want to do is put in some threaded holes so I can put a brake rotor on here. So SolidWorks does this kind of in one step, which is really nice and convenient. Fusion does it a little different. But I've figured out kind of a workaround that makes it pretty simple to do still. So what I want to do is I want to put in 5 threaded holes. They're going to be an M10 by 1 1/4 thread. And I want them at a certain bolt hole circle diameter and at a spacing of, I'm going to have 5 holes in here, so I want them evenly spaced. So what I'm going to do is right click on this surface and then create a sketch. Okay. And what I'll do for, let's say for clarity's sake, anyway, I'll create the bolt hole circle. So I'm just going to drag it out there and then escape, and I'm going to make that a construction line. Okay, and I'm going to define the diameter. Let's say this is going to be 90 millimeters. Okay. And what I want to do is I want to create 5 points on here, and I'm going to use those points to locate our threaded holes. So if I go in here and just click point, I can then put a point on the circle. And the first point I want to start vertical from the center line. So clicking that and the origin, and use the horizontal vertical constraint. And the next thing I'm going to do is I want to pattern these around this circle, and I want 5 of them. So I can do this manually with construction lines and, you know, dimensioning angles and all that stuff, or I can just create a pattern, which is going to be under our sketch tools here, and circular pattern. Okay, so the objects that I want to pattern are that point, and the center point I want them patterned around is here. And then a little box opens up and it asks me how many of these I want. Okay, so I want 5, and you can see that they're all patterned in there. I click OK. And you can see based on the diameter and the point being on this circle and the point being vertical, and then the rest of these points being evenly spaced for 5 points, everything is totally constrained. So nothing's going to move around, which is great. So I'm done there. And the next thing I want to do is put in my holes. Okay, so I'm going to go into my solid tools, and I think it's under modify. Nope, okay, I think it's under create here. Hole, there we go. So for our placement, we're not doing just one hole, we're doing multiple holes. So I'm going to click that. Our sketch points, I'm going to highlight that, and then I'm going to start picking our sketch points. Okay, that and that. Now we're done. And these are going to be tapped holes. So you can see there are different options here. What I've got is a simple hole. It's a tapped hole. I'm just going to go ahead and put in a full thread. It doesn't really matter because the machinist is the one who's going to go in and specify, how deep you can actually go with your threads. And then I'm going to do a typical drill. So this is going to be essentially like how I would machine these tapped holes. So what we want is we want our thread depth to be, or actually, you know what? Let me do this. Okay, so the reason I'm going to do this is because I think that when Fusion does the CAM side of things and starts doing the program, it's going to expect an offset thread, which means that we drill our hole for the tap quite a bit deeper than the tap is actually going to go. And that's going to prevent us from putting a tap into the bottom of the hole and breaking it off. Okay, so anyway, this is going to give us our hole depth right here. Okay, and these are going to give us our thread parameters. So for an M10, I'm going to want 15 millimeters of thread. So I can key that in there. Oops. Sorry, I hit enter too quickly. So anyway, I hit enter too quick. So I wasn't fully defining all that stuff that I wanted yet. So I'm going to just go in here and right click that feature. And then I'm going to edit the feature. And that's going to bring back our parameters so I can keep playing around with stuff. Okay, so we've got our 15 millimeters, 118 degree drill, which is typical. It's already picked out the tap drill. And then the depth of the hole, I want this to be, let's say, 1/8 of an inch deeper than our thread depth. So I'm just going to put in 0.5906, which is our thread depth, plus 1/8 of an inch. And here's where you pick the thread type. So this is an isometric, right? We can also do, where are ANSI metric? Okay, these are going to be our imperial threads, the ANSI unified screw threads. So if you wanted to do like a 1/4 20 or 5/16 18, those would be in there. But we're doing isometric. It's a 10 millimeter diameter thread. It's got a 1 1/4 pitch. 6H class is just thread tolerances. Odd that they don't have more of those. But we're just going to do that. And just go ahead and click OK. So now you'll notice too that this thread went through the hub body, and I don't know if I like that. So if this were Autodesk or SketchUp, you'd be like, well, shit, now I got to go back and redraw the whole thing. But this is Fusion, so we get to change things. Okay. So I didn't like how that turned out. So I want this body to cover up the thread or the tapped holes here. Like I don't want them to poke through like that. But I definitely want to have a hole deep enough to give me 15 millimeters of thread engagement. So what I'll do is I'll go back to the hub profile and I'll edit the sketch. So I guess one of the ways that you could make that section thicker where the holes were is you can bring this center circle up, right? And that's my dimension right here. So let's see what that would look like with 6 inches. Okay, and finish the sketch. And now you can see the whole thing rebuilt, and it is now thick enough that our holes aren't going to go through it. Now, another thing that I use a lot when designing parts is a section tool. So right now I can look at this and I can say, okay, it looks like our holes are good, but I really want to know how close are they to breaking through. Because, if you're machining this and you're drilling a hole and it turns out that it's really close to that outside edge, you're actually going to pucker that outside edge out, because the force of the tip of the drill is actually going to push that aluminum through. So one of the really useful things about this is I can go in here, or no, sorry, it's not that. It's under, I think, inspect. Let's see, section analysis, there we go. Okay, so again, inspect and then section analysis, and we're going to pick a plane that we want to cut. So I want to cut with that plane. Okay, and then go back to look at that dead on. And then just click OK. And we can see that we're not really close to breaking through. So that looks good. Now, the section analysis has now created its own folder. Okay, so this is stored as a view. And so the way that you get out of looking at everything in this is you can just hide that analysis. Okay, but because you've created that analysis, you can go back and keep looking at that as you continue to build out the model. So if I make some other features here and I wanted to look at them in that particular section, I can do that just by going ahead and making this visible. So I'm going to name this as our, let's say, M10 clearance section. So that way I know what it is, right? Because eventually I'm probably going to have a bunch of section views in here. So it's nice to just be able to click on that one and say, okay, right, that's what I was looking at. All right. So, okay. So we've got these. That's great. And I want to do them on the other side. So what I'm going to do is create another sketch and then do another pattern and then do another hole feature. And then I'm just kidding. I'm not going to do that because that would be stupid. Right. So what we learned is that we can mirror things in sketches, but you can also mirror features. So the way that we're going to mirror features is we need to mirror the feature across a plane. Okay. And this plane is dead center of our hub. And there's a reason that I drew, okay, there's a reason that I drew this sketch around the origin, okay, because I've got my center line for reflection right on the origin, and I've got my axis for the actual wheel hub on my origin. What that means is that our planes are going to be dead center on this sketch, which makes it very easy to do things like this. Okay, so I'm going to select my plane, and then I'm going to go under solid. I believe it's solid. It might be under modify. Let's take a look here. Okay, here it is, mirror. So the object type that I want to mirror is a feature. Okay, because I'm not creating a new body, but I've just put a hole in there, and a hole is considered a feature. So I want to reflect features, and then it's going to ask me to select what I want to mirror. So I'm going to select my hole feature, and then my mirror plane has already been selected. right? Because I opened this tool up when I already had that plane highlighted. Okay, so we get a preview of what it's going to look like. It looks good to me. And there we go. We've got holes on both sides and they're perfectly reflected. And if I have to go through and change something as far as like the hole diameter or the hole depth, that's going to be reflected across here. So I only have to change this once. So what I want to do here is I want to name that feature. Okay, so we're going to call it the brake rotor holes. And the reason is because it's going to make it clearer which feature is the one you can change, right? So if I clicked on, let's say I clicked on these and I wanted to go modify that feature, what I'm actually going to end up modifying, okay, so like edit feature, I'm actually going to modify the mirror, which is not what I want, right? Because the mirror is just reflecting the feature that I've already defined. So I want to make sure that I modify this one. Okay, so that's about 45 minutes so far. It's probably a good time to break. So I will continue this part on the next video.